Hello everyone, welcome to Mindspan Education. Last two videos we were discussing about the covariance and correlation. In this video we are going to look at few of the problems based on these covariance and correlation. Before I proceed with the examples, let me give you few updates. Recently we have launched our GATE DA 2026 test series. So if you would like to enroll on that test series, you just need to go to the mindspaneducation.com. There you will find all the details regarding this test series. You will have each and every details, how many number of tests are there, what are the structure of test, every details will be present there. So you can just go and explore the details of the test series. Currently we are offering 20% discount and this will be valid till 31st of July, and afterwards it will have the original price. Currently it is on 999, so you can just go and look at the details, you can explore, and even you can have few tests that we have already put as a free test. So all the previous year examination of GATE DA as a in form of the test series that are free to enroll, you can just look at and you can get familiar with our environment, that how we conduct the test and how we give the analytics and how we give the solution to each question, right? And what are the other features that we have included in our test series. So you just can go into the test series, and here we have the PYQ test series. This is the second card, that is the PYQ test series, and here this is free to enroll. You can just enroll and explore the complete environment on our platform, right? And once you are satisfied and you think that it would be fruitful for you to enroll our GATE DA 2026 test series, then you can enroll for it. Okay, now let's proceed to our problem, and let's do few problems based on the covariance and correlation. Let's look at the very first problem. We have given these two random variable x and y, and these two random variable are normal distribution. So, and it has the mean 0 and the variance 1. And we have two random variable z and w that is defined in terms of this random variable x and y. We have to find the covariance between the random variable z and w. So in order to find this covariance between z and w, we are going to make use of the properties that we have seen for the covariance. So this can be written as covariance of, so we can write, so everything that we know about the x and y, right? And z and w is also in terms of the x and y. So what we will try to do, we will somehow try to make everything in terms of the x and y, because whatever the information that we have is of x and y, right? So z can be written as 1 plus x plus xy square, comma w can be written as 1 plus x. So we need to find the covariance between these two. Recall from the property of the covariance. Let me recall you that we have already seen the very first property, this one, right? If you have some random variable x and y, and if you have the linear function of this random variable x, and you are trying to find the covariance between this linear function and this y, then at the end you have observed that it doesn't depend on this b, right? So what you can do, so this is directly equal to a times this covariance of this random variable x and y, and we have seen it for the special case where we have taken this expectation value of x and y is 0, and it will be also true for the case if these are non-zero, right? So this, so overall point is that we can directly drop this b. So let me show you how we can do that here. So this covariance will be, so simply from here we can drop this 1. So this covariance will be x plus xy square comma x. Right, and we have looked at one more property, and that property was given you as a homework problem. So let me now find this one. So here what we are trying to find, we have these 3 random variables, and we are trying to find the covariance between x plus sum of these 2 random variables, that is y plus z. And to make it simple, what we have taken is the each expectation of random variable is 0. So we can write this covariance as a product of expectation of this random variable. So product is x times y plus z, right? This we can write. If everyone has 0 expectation, we have seen that this covariance can be directly written as the product of expectation, the product of the expectation. Right, and now what we can do, we can proceed further, and that would be x times y plus x times z, and using the linearity we will have x times y plus expectation of x times z, and each have the expectation 0. So we can, this will be nothing but the covariance of x and y, plus this will be covariance of x and z, right? So simply what you can do, if you have something like this, right, some one random variable, that is the sum, or if you have some of the random variables, what you can do, you can simply distribute this covariance over this summation, right? So covariance of x and y plus covariance of x and z, right? And this will be true again for any general case, right? So just to see the property, we have make this simplification, but it will be true for any general case. Here simply what the same property we are going to use, what you are going to do, we are going to distribute this covariance over the sum, right? So covariance of x and x, so covariance of x and x plus covariance of this and this, covariance of xy square and x. Again recall, covariance of random variable x with itself is nothing but the variance of this random variable x, plus now we have one more simplified or alternative formula of the covariance. So we have seen the covariance of this random variable x and y can be written as expectation of the product minus the product of the individual expectation, right? So this is the property that we have already seen, so we can make use of here, and this can be written as the expectation of the product of these 2 random variables for which we are trying to find the covariance. So that would be x square y square minus the expectation of individual random variable, product of the expectation of individual random variable. So we have this random variable and this random variable, so expectation, product of the expectation of these 2 random variable. Now you will see everything is familiar, everything is in terms of the x and y, and you will have each and every info, because the variance of this random variable, that is 1, and these 2 random variables are independent. So this can be written as expectation of x square times expectation of y square, right? Because these 2 random variables are independent, so expectation of x square y square can be written as expectation of x square times expectation of y square, right? And expectation of x square is nothing but the variance of this random variable x and variance of this random variable y, and both have the mean 0, right? So this will be, let me write down also, so that expectation of x square, expectation of y square minus, and here we can again, this x and y is independent, so this can be written as expectation of x times expectation of y square times this expectation will be iska whole square, right? And what is this? This is nothing but the variance, right? Because the mean of this random variable is 0, so variance would be expectation of x square. So that would be 1 times 1 minus the expectation of this is 0 chi square times the expectation of y is also 0. So overall you will get 2. So the answer for this question is 2. Let's proceed with further question. So you see, we have looked at the various properties, right, in order to find this covariance between random variable w, z and w. Even we can use of the core definition of this covariance. What is covariance? So we can make use of this expectation of z minus mean of this z times w minus mean of this random variable w. So we can make use of this. So again, you have to put this here, and you have to find the mean of this z, then put here, find the w, put here w, and you have to find the mean of this w, and you have to do some algebraic manipulation, and ultimately you will reach to here. But it is easier to directly use the property, so that you have the less calculation. This question is finding the correlation coefficient using your intuition, right? Because this is not something that you can find the exact answer, but we have seen the correlation of two random variable. So the correlation here we are talking about the random variable y and x, right? And we have given some data point, and we have to somehow guess what will be the approx correlation between these two random variable x and y. So we have seen we will have the linear relation between these two random variable x and y if the absolute value of correlation is 1. That means if correlation coefficient is 1 or minus 1, then we will have a linear relation, the linear relationship between x and y. That means you will have some straight line. If you try to plot between graph between x and y, you will have some straight line, right? And all the sample will lie on that. Obviously all the sample will be on the line only when they will have the linear relationship. So let's go through each and every plot, and let's try to comment about this correlation coefficient. You see here we have the linear relationship, right? Because if x is high, then y is also high, right? And if x tends to low, then y also tends to low. X and y following, right? Both are following the same, right? If x is, but here the point is, if x is positive, then if x is bigger positive, then y is bigger negative, right? And x is smaller positive, then y is also smaller negative. So they are in linear relation, but in negative sense. If x tends to be, on an average, if x tends to be larger, then y tends to be smaller, right? And they have the perfect linear relationship, negative relationship, so the covariance, so the correlation coefficient would be -1 in this case. Here we do not have the perfect relationship, but somehow they are, x and y tends to follow each other, but not, they are not in linear relationship, right? Because due to these data points, it will have, for the greater value of x, y is also greater, but they are not in the perfectly linear relationship. It has some positive correlation coefficient because x and y tends to follow the same path, not exactly. If x is larger, then y also tends to take the larger value, but they are not in the exact linear relationship. We can say we could have some positive correlation coefficient, and I don't know, might be we can give it approx 0.7, 0.8, something like that, right? So just to give you the sense of the correlation coefficient, we have picked this example, and if you try to find the exact answer, you will not find it, because for that you need to have the exact data. Here we have the positive correlation coefficient, and we have the exact linear relationship between x and y. So this will be the relation, the correlation coefficient would be positive. Here we cannot find any kind of, or completely it is non-linear, right? So here in this case we can say the correlation coefficient would be 0. Here also we could say the correlation coefficient would tend to 0, or you can say maybe 0.1, something like that, and it will have the negative. So let me modify that one. It will not be 0.1 or something like 0.6, right? And it will have like 0, and this will have +1, and this will +9 or +8, whatever, and this will have -1. Alright, so you got the idea about the correlation coefficient. So given the plot, if x and y have the exact linear relationship, then it will have the correlation coefficient that is +1 or -1. Let's proceed to next question. Let's try to look at this problem. Suppose x and y are random variable where y is equals to -5x plus 2. Find the correlation coefficient between x and y. Even you do not need to pick the pen to calculate the correlation coefficient for this question. It is directly visual that what it will be. It will be, let me first of all calculate. Meanwhile, you can think of directly what could be the answer. And if you have got the answer before calculating this, let me know in the comment section. So we are trying to find the correlation coefficient between this random variable x and y, and it is nothing but the dimensionless version of the covariance of this random variable x and y. And this is how we can write the dimensionless version of this random variable x and y, covariance of this random variable x and y. So this is correlation coefficient is equals to covariance divided by the product of the standard deviation. So first of all, we need to calculate the covariance between this random variable x and y. Y has given in terms of the random variable x, so we can write that is equal to covariance of random variable x, and y is -5x plus 2, right? Now we can simply drop these two, we have seen from the property, so that would be the covariance of x comma -5x. This can be written as, So this is minus, so this is A, right? So covariance of A times AX will be A times, so A is minus 5, covariance of x comma x. Again I have used the property, right? And now again using the property, covariance of x with itself is nothing but the variance of this random variable x. We have found this. Now we have to find the standard deviation of this random variable x and y. So let the standard deviation of this random variable x is sigma x. What will be the standard deviation of this random variable y? If x has the standard deviation x sigma x, then so y is 5 times x plus 2, right? Then what will be the standard deviation of this? What will be the variance? So we have seen this property of variance, right? That the variance of this random variable ax plus b is nothing but the a square times variance of this random variable x. So if variance of this random variable x is sigma square x, then the variance of this random variable x ax plus b would be a square sigma x square, right? This is we have seen already in the property of the variance, right? So what will be the variance of this? 25 times variance of random variable x, that is sigma x square. What will be the standard deviation? Root square of that. So that would be 5 times the standard deviation of this random variable x, right? Then what will be the correlation coefficient of this random variable x and y? The covariance is so minus 5 times the variance of this x and product of the standard deviation, and we have found that the standard deviation of this random variable y is 5 times sigma x. We can write like this: 5 times of variance of this random variable x divided by 5 times sigma x square. This sigma x square is nothing but the variance of this random variable x. So this will get cancelled, this will get cancelled. Overall you will have answer that is minus 1. You could have directly seen this y is a linear function of this random variable x. So the relation between x and y is linear and it is opposite or in the same direction. You can just simply look at the slope. Slope is negative. That means x and y are in linear relationship with opposite direction, right? So that is why we have got the correlation coefficient that is equals to minus 1. So in this question you do not even need to pick the pen, you can directly answer this kind of question. If you found the linear relationship between x and y, just look at the slope. The correlation coefficient could be plus 1 or minus 1 depending upon the slope of the line. Let's look at more problem based on the correlation and coefficient covariance. Now let's look at this question number 4. Two fair 6-sided die are rolled, one green and one orange, with outcomes x and y respectively. For the green and orange, compute the covariance of these two random variables. So what we are trying to find is the covariance of x plus y and x minus y. We have seen one of the property that we can distribute this covariance. So what we are trying to find is so we have this sum, right? So we are going to simply distribute this covariance. So we have already seen this property. So this will be the covariance of x times x, that is the covariance between x and x, and then covariance between x minus y. So minus times of covariance between x comma y, and then covariance between x, y and x. So plus covariance between y and x, Then covariance between y and minus y, that is minus times of covariance between y and y. So these two will get cancelled, right? Because if you find the covariance between x and y or y and x, it is same, right? So these two will get cancelled. Now what is this? Covariance with itself. Covariance with itself is nothing but the variance of this random variable x minus variance of this random variable y. What is this random variable x? This random variable x is, so how we have defined this random variable x and y respectively for the, so two fair six-sided dice I roll with outcomes x and y respectively for green and orange. So x can take the value 1 2 3 4 5 6, y can also take the value 1 2 3 4 5 6 with equal probability 1 divided by 6. So their variance would also be equal. So overall we will have the covariance between these two random variables, that is 0. Now let me ask you a question. Can we say that these two random variables, so random variable x plus y and x minus y, will be independent? Recall what we have learned. We have learned if two random variables are independent, then the covariance will be 0. That is 100% true. But the converse statement is not true. We cannot comment about the random variables if we have found the covariance 0. If we have no info about the random variables and we have found that the covariance is 0, we cannot comment about that those two random variables are dependent or independent. So the question for you, given we have found the covariance between these two random variables are 0, can you tell me that if these two random variables will be dependent or independent? Let me know in the comment section. Let's proceed with further examples. Question number 5. Let x, y and z be random variables where x and y are uncorrelated. What do we understand by uncorrelated? Uncorrelated means the covariance will be 0. If covariance is 0, the correlation coefficient would be also 0. That is what mean by the uncorrelated word. The mean of the random variables we have given. The expectation of random variable x is 1, y is 2, z is minus 1, and the product of these expectation x and z is 5. We have to find the covariance between random variable x and y plus 2z. So that everything we have given in terms of the random variable x and y, and this is the one more information that we have given, that x and y are uncorrelated. First of all, try to simplify this covariance between these random variable. So we know this can be written as using the property, so that would be covariance of x, y, then plus covariance of x to z. Sorry, x, y we have done the, sorry, so x, y we have done 1, and then we will have this. So the covariance plus the covariance of x and 2z. We have given this information that the x and y are uncorrelated. That means the covariance between x and y will be 0. So this term will be 0, plus this term can be written as 2 times the covariance of x comma z. So we have to find ultimately this one, the covariance of x comma z. We have more infos. So using the alternative formula, we can find the covariance of this x comma z is nothing but the expectation of this random variable x and z, and this is also we have given minus the product of the individual expectation, that is expectation of this random variable x times the expectation of this random variable z, right? So that would be 5 minus the expectation of random variable x is 1 minus the expectation of random variable z is also given, that is minus 1. So here we will get 5 plus 1, that is 6. Now we can put the value, that would be 2 times the covariance of x and z, that is 6. So the ultimate answer is 12. So the correct answer for this question is 12. Let's look at more question. Let's look at this question number 6. This one is also easy. We have given this random variable y in terms of this random variable x, z in terms of this random variable x, and the information about this random variable x is it is uniform random variable between -1 and 2. We have to find the expectation of y, z, variance of y, variance of z, covariance of x and z, and the correlation coefficient of y and z. So we have given the PDF of this random variable x that is uniformly distributed between -1 and 2, and it will have the height that is 1 divided by 3. First of all, we have to find the expectation of y. So the expectation of y is equal to, we can write y is given in terms of the x, so it will be same as the expectation of x plus 30. We can proceed further with the linearity, that would be expectation of this random variable x plus 30. And what's the expectation of this random variable x? So that is 2 minus 1 divided by 2, that is 0.5, that is 1 divided by 2. So the expectation of y would be 30.5. B, expectation of z. Again we have given this z in terms of this random variable x, so z can be written as 3x minus 4. Using the linearity, we can write 3 times this random variable x minus 4, and 3 times expectation of this is half minus 4, so you will have 8 minus 3, that is minus 5 divided by 2. Variance of this random variable y. So y will be also uniformly distributed, right? So using the transformation, you can even find what will be the PDF of this random variable y. You just need to shift this PDF 30 unit left, and you will have the you have to shift this PDF 30 unit right, and you will have the PDF of this random variable y, and that will be again uniformly distributed. So we can directly use in order to find the variance of this random variable y, that is b minus a divided by 12, b minus a ka whole square divided by 12. And what will be the PDF of this random variable y? So you just need to shift 30 unit right. So minus 1 will get shifted to 29, and 2 will get shifted to 32. So b is 32, so that would be 9 divided by 12, right? Because this difference is how much? 3. So 3 minus 12, so 3 ka whole square divided by 12, that is 9 divided by 12. Now the next part D is we need to find the variance of this random variable z. So that will be again uniformly distributed, right? And how we can find the variance of this random variable z? Let's first find how the PDF of this random variable z will look like. So we have already seen the transformation of random variables, right? So first we need to scale the PDF of this random variable x by 3. So if you scale on the x-axis, so -1 will be -3 and 2 will be 6. So 2 times 3 will be 6, and you will have the uniformly distributed. Since you have scale in the x-axis, and you need to also scale on the y-axis, so that the overall area is 1, right? And you have the probability that is uniformly distributed, that is 1 divided by 3. So in order to make this area 1, you will have to scale on the y-axis also, right? And we have seen all these things. So this will be scaled by 1 divided by 3 units, so it will be 1 divided by 9, right? So again you calculate the area, then it will turns out to be total area 1. So we have scaled. Now the next point is to shift. So here minus sign is there, so we need to shift this in 4 unit left. So 4 unit left, if you shift this PDF to 4 unit left, so -3 will get shifted to -7 and 6 will get shifted to 2, right? 4 unit left. So this is the PDF of this random variable z. Now we need to find the variance. So variance is that would be b minus a. So 2 minus 7 divided by 12 is the whole square divided. So 7 plus 2, that is 9. So 81 divided by 12. Right. So this would be the variance of this random variable z. Now coming to part E, we have to find the covariance of this random variable x and z. Covariance of this random variable x and z, that can be written as covariance of x. X is nothing, so x is x, and z is 3x minus 4. 3x minus 4. So we can directly cancel out this one. That would be covariance of x, that will be equal to covariance of x with 3x, and that would be 3 times the covariance of x with itself, that would be equal to 3 times the variance of this random variable x. So 3 times, what is the variance of this random variable x, that we can find from here, that would be 2 minus -1 ka whole square divided by 12, and that would be 9 divided by 12. 3 times 9 divided by 12, so that would be 9 divided by 4. Now next question is, what will be the correlation coefficient of this random variable y and z? You do not need to even calculate this, the covariance between this random variable. So this will be f part y and z. Y and z. So you can write y is equals to x plus 30, right? And if you try to find x from here, so x will be z plus 4 divided by 3 plus 30. So y and z have the linear relationship and the slope is positive, so we can directly say that the correlation coefficient will be +1, right? And if you are interested to find the correlation coefficient, we have done multiple examples. You can proceed and find the correlation coefficient between y and z, and you will found that it will turns out +1. All right, so I think we have done 6 example. If you would like to solve more such example, we are already uploading or creating the practice problems on our platform on mindspaneducation.com, right? So we have already created a lot of, I think more than 150 question in the probability. Right, let me show you so that you could have idea that what is going on behind. So let me show you for the probability. So the videos are already on the YouTube and as well as on our platform, right? So you can go through and access the video, but apart from this video, for the examination point of view, you need to practice a lot of problem, right? So we have created a lot of practice problem. You see right now we have uploaded approx 150 question in probability and statistics. So and even those are, we are trying to manage that, put it in chapter wise. So each chapter will have 10, 5, 6 question, so that you at least get to know that what kind of concepts are there in probability and statistics. The GATE DA official syllabus, the topics has mentioned, right? But that topics have a lot of interlinking between other topics that are not mentioned there, right? So you need to also go through those concepts, right? And you need to practice problem and you need to understand the subject, right? And once you have good understanding of subject and enough practice problem, right, and you have done the enough practice, then you will have a very good confidence, right? And you will attempt the any test or any examination with full confidence. So you see, we are trying to put these questions such that it inlines with our videos lecture, right? And these are not the questions in any format. By keeping in mind that you are going to attempt the GATE examination, all the questions are with respect to the how you see in the GATE examination. It will have the MSQ type, numeric type, MCQ type, right? So we are trying to find the question, create the question and put it in a way so that you can practice more number of problems, right? So you can go through and you just need to, even we have make it so affordable that you will not have to even think twice while buying these practice problems or buying these to get enroll this within this course, right? So it is up to you if you want to have the benefit of that. So we are already solving a lot of problem throughout our exercise problem, throughout our videos, and those problems are good. Even ultimately you will be learning from those problems that we are solving in the videos lecture that are available on the YouTube. Apart from that, those are not enough because I am solving, you are not solving, right? You need to have the hands on the problem, right? And we are also trying to put the solution of each and every question. So let me show you one of the cues. So if you submit the cues, then you can see the solution of each and every question. So शायद ही कोई क्वेश्चन ऐसा होगा जिसमें कि सॉल्यूशन ना मिले, बट आई थिंक each and every question you will find the solution, right? So ultimate goal हमारा ये है कि you need to learn the subject, right? It doesn't matter how good I am or how bad I am in the subject. What matters is that how you understand the subject. What is your perspective, how you see the subject, and how you are going to make use of that, right? So that is the point, that is the core thing that we are keeping in mind. So at the end you will have to deal with each and every situation. So that let's prepare for that and let's अपने आप को प्रिपेयर करो आप उसके लिए, एंड देन अल्टीमेटली आई थिंक यू विल हैव अ good things in your hand, right? So that is all. You can go, and up to you that if you want to have the practice problem, more practice problem, then you can enroll for this probability and statistics. And also you will have the notes, that whatever I am writing, the annotated notes will be also there in the resource section. Similar for the linear algebra, that is also we have done that, right? In linear algebra, let me show you that I think more than approx 300, I think more than that 300 questions we have in the quiz part. 271 question total, 271 question, and we will be still uploading more question. So I have just uploaded starting the PYQs from all different branches in the linear algebra, and we have already uploaded the chapter wise problems for each chapter, right? So you can just go watch the lecture, attempt the questions, right? So that is all, right? And similarly for the calculus, that we are doing that, right? And the calculus lecture will be resumed soon, right? And so calculus, there is nothing much to talk about in the calculus, but everything will get completed by the time, right? So everything will be get completed on time. So even on the calculus you can go and look at the quizzes, right? So that is all from in this video. Thank you so much.